G'day. One major traffic movement in the morning peak is from the Eastern Freeway queue at the Yarra River at Alphington to Hoddle Street, down Hoddle Street, past Victoria Street, down Punt Road and across the Yarra River at Alexandra Avenue. The options that apply for this movement can be replicated for many other movements along Hoddle Street, but this movement only is used to illustrate options. We can reduce travel time in Hoddle Street and Punt Road within the existing footprint and for modest cost. Metering, capacity increase and queue jumping will reduce the travel time from 40 minutes in stages to 25 minutes, 16 minutes and then 8 minutes. Say Gibbs Street signals have 42 seconds green, 18 seconds red. 60-second cycle times are drawn up the page. Traffic leaves Gibbs Street for Victoria Street at 60k for 521 metres and it arrives at Victoria Street 31 seconds later. Coloured magenta, distance drawn right to left. Victoria Street signals have 33 seconds green and 27 seconds red. Signals are said to be linked when the end top of the platoon leaving Gibbs Street arrives at the end of the green at Victoria Street. This fixes signal timing and linking is done in the peak direction. Signals must have the same cycle length. But traffic in the counterlink direction from Victoria Street, coloured cyan, travelling at 60k for 554 metres, arrives at Gibbs Street 33 seconds later, 6 seconds too late for the green signal. So the last 18% of the platoon has to stop and wait 18 seconds. Average time lost is 18% of 18 is 3 seconds. Metering, by limiting traffic flows to practical capacity, allows operation with green waves and can give 5 minutes travel time from Eastern Freeway to Alexandra Avenue, 24/7. Average the travel time between intersections, add it up and count the signal cycles. But if there are normal signals in the middle at Language Street, traffic leaves Gibbs Street and arrives at Langley Street 15 seconds later. Now traffic in the counterlink direction from Victoria Street arrives at Langley Street 19 seconds later, 16 seconds early. So all the platoon has to stop and wait 16 seconds. Continuing in the counterlink direction from Langley Street, it arrives at Gibbs Street 14 seconds later, 20 seconds too late. So the last 62% of the platoon has to stop and wait 18 seconds. Average time lost is 16 plus 62% of 18 is 27 seconds, an extra 24 seconds because of one signal. If through and right are banned from Langley Street, that is left in, left out and right in permitted, each direction in Hoddle Street can be linked without delays at Langley Street, saving the 24 seconds from the Hoddle Street counter-peak traffic. So minor intersections must be left in, left out and right in, and pedestrian crossings staged to avoid excess stops. Traffic lanes have a capacity of about 2,000 vehicles per hour of green at signals. This is described as 100% degree of saturation. More than 100% degree of saturation and traffic can take more than one signal cycle to pass the intersection. If one lane is reserved for 40 buses and 3 general traffic lanes operate congested, capacity is only 6,040 vehicles per hour of green. Less than 90% degree of saturation is described as practical capacity, 1,800 vehicles per hour of green. For a 4-lane carriageway, practical capacity is 7,200 vehicles per hour of green. Traffic is free-flowing, can readily change lanes, and the green wave, linking, can be given to traffic. So, if only 1,800 vehicles per hour of green are permitted by upstream signals, there's no need for bus lanes. Doncaster buses are better served by metering than by bus lanes, less delay at signals. Metering must be extended south of Victoria Street, and that benefits the Punt Road bus. Bus queue jumps must be set back, that is, bus lanes terminate at one green phase queue length before the entrance to the metered length, such that buses get through on the first signal cycle, but general traffic must fully use all lanes at the stop line if capacity is to be maintained. New setback bus lanes must be installed on Punt Road, south of Alexander Avenue, and on Hoddle Street, north of the Eastern Freeway. Replacing existing bus lanes by metering increases capacity by 20% and reduces travel times by 15 minutes. If the existing capacity is increased, travel time and the total queue length for the free queue decreases, but demand increases. Metering increases capacity, reduces travel time, and so increases demand, but the queues on Hoddle Street disappear, replaced by an increase in the freeway queue. If capacity is further increased by two-phase intersections, travel time is further reduced, demand further increased, and the freeway queue reduced. If queue jumping is permitted for most traffic, travel time for the free queue increases, demand decreases, but the freeway queue can be decreased by merging two lanes to one near the freeway exit. Turn phases do not need to be at an intersection, and turns are best processed on the approaches in parallel with, that's the same time as, the cross traffic. This provides 50 to 70% more time for through traffic and 200% more time for turns at the main intersection, which is then called a two-phase intersection, or 2π. 2π reduced travel time by a further 9 minutes. 2π require a treatment of right turns that can either be a continuous flow crossover on the approach or a P-turn. These need not increase the footprint. A continuous flow approach, right turns cross to a right-hand service road before the intersection, is usually most efficient because traffic only passes the intersection once. Capacity for the approach crossover should exceed the capacity at the intersection. There's always more through volume at the right turn crossover for a continuous flow intersection because left and right turns from the crossroad are added to through volumes. So there's less time allotted to the crossover than to the cross traffic at the main intersection. Tandem or even tridem, that's multiple crossovers, are often required to keep the approach capacity higher. But at Victoria Street, Hoddle Street, the south approach is a low volume right turn, 100 plus vehicles, and it's better to use the lane as a through lane and get 1,000 plus vehicles. Also on the east, Victoria Street approach, right turn is queue on the tram track, and it's better to make them go through and do a U-turn downstream. Both of these P-turns pass the intersection twice, but the capacity is improved. Common Utah practice of having continuous left turns, their right, requires an additional lane, and this is wasteful of width. Better to have another through lane for capacity. Utah practice is also to have pedestrians separately cross right and left turns, with left turns often being continuous. This is complex for pedestrians, requires staging when turns are in separate phases, and requires crossing more lanes. Left turns must expect to stop for pedestrian safety rather than have a continuous left. Better that both left and right turns are in the same slip lane, crossing with pedestrians under full signal control. Continuous flow intersections have right and left turners entering the same departure in the same phase. Left turn must give way to right turns so the right does not get stranded at the end of the phase. So all right turns can have an early cut-off and all left turns can have a late start. Pedestrians cross the slip lane after the early cut-off from one approach and before the late start from the adjacent approach without reducing capacity. A concept of stewardship must be adopted, meaning the best practical capacity is achieved given the road space available. Each intersection must have a designed traffic load, preferably from assignments, and each option rated for the practical capacity it can provide. Existing practical capacity for Hoddle Street is only 40% of 2-pi capacity, with metering. That is simply not good enough. Only the best will do. Smart roads is not an excuse. Given the capacity, the allocation of priority by mode and time can meet the smart roads objectives. Funding or safety is not an excuse. Positive guidance, signing, must provide drivers with the ability to protect themselves at every hazard, since it is impractical to remove all hazards. Generous width standards should not be used at the expense of capacity. Hoddle Street, south of Victoria Street, desirably has 8 lanes to match contiguous roads. Travel time on congested roads must be minimised. Metering, linking both ways must be supplemented with queue jumping to the greatest possible extent. Low travel time targets must be set. Most drivers overcome their aversion to tolls if they can queue jump to save 13 minutes for $1.50. One lane must be provided for those who do not wish to pay, but metering requires that they queue, although less than now. Buses and high occupancy vehicles can queue jump for free. Single person vehicles will be tolled, and the toll set high enough to allow metering. Queue jumps save a further 8 minutes for tolled and high occupancy vehicles, and that travel time can be held constant with time. Only the queue time and the toll grows into the future with increased demand. All crosswalks must permit cycling with cycle lanterns and be timed with presence detectors. It's never safe for cyclists to be on road on arterial roads. They should always have low stress off-road options. Cyclists on footpaths must be in shared zones, 10Ks. Separate networks must be configured for cycling, as bicycle boulevards like Napier Street, Fitzroy, and have underpasses of arterial. Proposals are a diverging diamond with tolled queue jumping on the Eastern Freeway and a new bus lane north on Hoddle. Left in, left out and right in at Truro Street, continuous flow intersection at Johnson Street, and left in, left out and right in at Studley Street pedestrian crossing. Continuous flow intersection at Gipp Street, and left in, left out and right in at Stanton Street pedestrian crossing. Left in, left out and right in at Langley Street bike path and pedestrian. 2-pi intersection at Victoria Street with 2 continuous flow approaches and 2 P-turns. Bus lane setback and dual Trident crossover. Left in, left out and right in at Albert Street bike path and pedestrian crossing. Left in, left out, right in at Hotham Street pedestrian crossing. Left in, left out and right in at Freeman Street pedestrian crossing. Continuous flow intersection at Bridge Road Wellington Parade with 2 tandem crossovers and Wellington Parade stub not used. Left in, left out and right in at Rowena Parade pedestrian crossing. Left in, left out and right in at Richmond Terrace pedestrian crossing. Continuous flow intersection at Brunton Avenue with new right turn from the north. A 2-pi intersection at Swan Street Olympic Boulevard with 3 continuous flow approaches and a double P turn from the north. Continuous flow intersection at Alexandra Avenue, keeping the right turn bans from Punt Road. For the example movement, the outcomes are volume increases by 1/3, green wave in Hoddle Street Punt Road, freeway queue increases by 500 metres, travel time reduces by 32 minutes for 2/3 of the general traffic and by 19 minutes for those who queue, Doncaster buses slightly improved and Punt Road bus travel time reduced by 22 minutes.